Hello and welcome to episode 19 in our Pharmacy Calculations practice series. And we've got a few questions today that were posted on our Facebook study group, so we're going to walk through each one of these. And the first one was essentially you receive an order for 1.2 liters of a 10% oral solution, but you only have a 12% solution in stock. How much sterile water and how much 12% solution will you mix? Now, there's a couple different ways you could do this. We can solve this by setting up a series of proportions and solving by cross multiplication, or we could set up an alligation. Either way would be totally fine, so whatever you're more comfortable with. I think for the sake of time, we'll do this via alligation because I think that's a little faster for this one. And if you've seen our prior videos, hopefully you'll remember that to do alligation, you're going to set up a tic-tac-toe diagram, just like this. And in the upper left, you're going to put the higher strength of solution that you have on hand. And in this case, it's 12%. And the bottom left, you're going to put the lower percent concentration you have on hand. In this case, sterile water is actually going to be 0% of whatever drug this question is inferring. And you're going to put your target solution in the middle box. And we're trying to make a 10% oral solution here. And now we can take this higher concentration, subtract the desired concentration, and we're going to put that number in the bottom right. Then we're going to take our desired concentration, subtract our lower concentration on hand, and put that value in the upper right. And in this case, 10 minus 0 is 10. So what this tells us is that we're going to have 10 parts of 12% to every 2 parts of 0%. And so we have a total of 12 parts. And we can now take this information and we have to make a 1.2 liter solution. So we can take that 1.2 liters and we can multiply that by our proportion of 12%, which is going to be 10 parts out of a total of 12 parts. And that's going to tell us how much 12% solution we're going to need to use. So 1.2 times 10 divided by 12 is going to be 1 liter. And then we can figure out how much sterile water by simply taking the 1 liter of 12% that we're going to be using and subtracting that from our total of 1.2 liters, and that's going to be 0.2 liters. So we're going to have 1 liter of 12% solution and 0.2 liters of sterile water. Now, if you have a multiple choice answer set, you may be asked in milliliters, and we can convert these values to milliliters by multiplying by 1,000, because that's our conversion factor from liters to milliliters. So this would be 1,000 milliliters of 12%, and then 200 milliliters of sterile water. Now, if you want to see this solved the other way via proportion, send us a message. We'll be happy to post it, but this would be the faster and easier way to do this. Okay, now our next question states that an IV infusion of 1 liter of a 0.5% active drug in D5W has been ordered to be administered to a patient over 10 hours. The administration set is calibrated at 15 drops per milliliter. What flow rate will be used in drops per minute? So at the outset, we can see that there's a couple of conversions that are going to need to take place here. So they're providing us the volume of solution in liters, but the drop ratio that's given to us is given in milliliters. They're telling us this is infused over 10 hours, but we need to calculate how many drops per minute. So in this information here, we don't need to know. 0.5% active drug. Sometimes these questions can confuse you because they give you more information than you need to actually solve the question. But we'll focus in on what we need to know. And just to make this a little easier and simpler, the first thing I would do is convert liters to milliliters. And you really need to memorize your unit conversions for the PTCE, so you should already know that 1 liter equals 1,000 mLs. We don't need to do any other conversions there because we're simply just dealing with 1 liter. So we have 1,000 mLs of solution. We know we're going to infuse it over 10 hours, and we can convert that to minutes by taking 10 hours multiplied by 60. And that's going to be 600 minutes. So essentially we're giving 1,000 milliliters over 600 minutes. And now we need to figure out what the flow rate is in drops per minute with a known drop set kit that's calibrated at 15 drops per milliliter. So the very next step I would do is convert your 1,000 milliliters to total amounts of drops. And we can do this by setting up a proportion. We're going to put our unknown in the numerator on the right side, as we always do for consistency. So how many drops are in 1,000 milliliters? When our known ratio is going to be on the left-hand side, we need to keep the units consistent, is going to be 15 drops per 1 ml. And then we can solve this by simply taking 15 drops divided by 1 ml. We then cross multiply to that 1,000 ml. Your milliliter units cancel out and we're going to be left with drops. So let me get my calculator. 15 divided by 1 times 1,000 is going to be a total of 15,000 drops. And now we need to know what the flow rate is in drops per minute. We can set up another quick proportion for this. So we want to know how many drops per 1 minute when our known total amount that we're giving is 15,000 drops in 600 minutes. And again, you'll take that same cross multiplication approach. So 15,000 divided by 600 multiplied by 1 minute, and the answer is going to be 25 drops per minute. All right, and the last question that was posted states that an IV has been ordered to run for 4 hours at 10 drops per minute with a drop factor of 20 drops per milliliter. The solution in the bag is 750 milligrams of active drug dissolved in 0.5 liters of D5 normal saline. How many milligram of the active drug will the patient receive in 2 hours? So we have a lot of information. I think we're going to need to make several conversions or several proportion and cross multiplication conversions here. I would probably start with trying to figure out how many drops total the patient's going to get in 2 hours, and we can go from there. So we have a order that's running at 10 drops per minute. We don't really need to focus in on this 4 hours because they're only asking us how many milligrams the patient's going to receive in a 2-hour period. And we'll make some real quick conversions there. We'll just do it in our head as we set up the proportions. So if we know, we'll start our first one is how many drops will the patient get in 120 minutes? Okay, that's equivalent to 2 hours. That'll be good info to start with. When our known rate is going to be 10 drops, remember we keep our units consistent on both sides, per 1 minute. Okay, and we've already shown this on the other slide, so I'm not going to write this out again, but we'll take 10 divided by 1, cross multiplied by 120. So we're going to have a total of 1,200 drops. Okay, and now we can figure out how many milliliters the patient gets by taking our other ratio that we're given here, which is 20 drops per milliliter. And we're going to figure out how many we're going to get when we have 1,200 drops. So we set up our proportion to solve for milliliters. So how many milliliters are in 1,200 drops when our known ratio, and again, we're going to have to flip it this time to keep the units consistent, is 1 ml per 20 drops. And we'll take our same cross multiplication approach. So we'll take 1 divided by 20, multiplied by 1,200. So we're going to have a total of 60 milliliters of this drug solution that the patient is going to receive in a 2-hour period. Now we need to figure out how many milligrams that is. And we can do that by setting up one final cross multiplication. So we're going to have X milligrams per 60 ml when we know that there's 750 milligrams per 0.5 liters. Now we have to convert that to milliliters. Conversion factor is 1,000, so it's 500 milliliters. So we know there's 750 milligrams per 500 milliliters. And again, we'll do our cross multiplication. So 750 divided by 500 times 60. Our answer is going to be 90 milligram of drug. Now, any questions about this whatsoever, feel free to reach out to us. Some people like to do these cross multiplications in one long line. I always teach it broken down like this so you can understand better each individual conversion. But obviously there's more than one way to do this. But this method, if you do it consistently, you'll find you'll do pretty well in these types of questions. If you need help with any other questions or have any ideas that you'd like to see on future videos, please reach out to us at our contact information here. Thanks for watching.